Hello everyone, my name is Yogesh and today I am recording this lecture. In this lecture I will be covering one of the common issue which is faced by DBS developer and even the server management team on the production server, that is SQL servers lead into 100% CPU utilization or near about 100, and also consume all the memory resources which are available. Now this tutorial will only help you in when you have checked like the SQL server is the culprit, like you have done some of the common checks, like if there is availability of physical memory and there is no other process which is causing issue, etc, etc. What are the common checks which you must check? So once you are sure like SQL server is culprit, then only this tutorial will help you. Now in this tutorial I have basically I have two methods of fixing this issue. One is the traditional method which you must be knowing it and you must be all of you must be following it, or second method which maybe you don't know but maybe you are aware of it, but for the sake of this tutorial I will be cover both of the method. So and also both the method are not a same like two different approach for a common solution. It is two different method applied over two different cases. Though our goal is same to lower the CPU usage, but they are applied over different scenarios, so nothing in common between these two methods. Okay, now before starting this, let me tell you one more thing. Like there is a myth which most of the developer and DBS like the junior DB also follow, like only longer running query is a problem. That is not always true, because in actual longer running queries can be a problem, but in spite there are other queries also which can cause issue, like query having maximum worker time are also problem, and secondly the query which is having maximum execution count can also cause a problem. Like suppose you have a query which is executed in 1 millisecond or 10 millisecond, but the you can say the number of execution hit on the server is more than 1 lakh within a millisecond. So now at that moment your server will say, oh my god, what is happening? Okay, so that could also be a possible issue of like possible issue for the CPU utilization. Okay, for all in this tutorial I will be using this SQL load generator tool to generate some stress on SQL. This will not generate the actual production stress, but it will generate stress near to the production level. Okay, when we will be using it, and I will be using just simple task manager to show you the CPU usage. Now if you will see, my CPU usage is just normal, like it is just fluctuating between 6 to 30.40%, but it is normal. It is not that much big, which can cause my like if this will do the production server, it could cause an issue. So now also I have for in this tutorial I will be using Northwind Database. Okay, Northwind Database I am having one table which is having around 1 plus quarter lakh of records. So what I am doing is to make it execute for a long time. I have done some union to it. Okay, now let me copy these and let me add few more union to it. Let me add, okay, so that yeah, this is not the actual production simulation, but just I am showing you how it affects the system. Now you see the CPU usage is normal and I start executing this query. Now if you will see, the CPU usage is getting increasing and is also not getting lowered. Now how you can check this one? First I told you the traditional method, we use this SP-who2 stored procedure to check the process having causing the issue on the server. Now you will see the server is keep on like increasing the usage. So now when you are using the SP-who2, you must be aware of one thing, like you only have to look for SP ID which is greater than 50, because below than 50 are been reserved by SQL server itself. Now the CPU usage is totally increasing. Now I see a process which is on the Adventure Work database and having the CPU time increased. Like CPU time, whenever I am executing SP-who2 again and again, the CPU time is increasing. So means there is a query which is this is a process which is continuously executing and which is causing an issue. So to check the definition of this process, I have to use this dbcc input buffer. I just have to pass the SP ID of this and I can look into the query. Now if it is a select query, you can kill it if it is required, because it must be used by some report or something like that. But if it is a transactional query, you must not be doing this on production, like killing this process. You have to wait till the time it get over. After the transaction is done, you can then look for the possible solution to minimize the response time of that transaction. Now if I want to kill this, I will just kill this process. Now if you will see, the process is out, okay, and my CPU usage is again low. Now this is the simple solution which I told you, like this is the traditional method. Most of the DBS follow this for the select query most of the time. Now coming to it, normal scenario. Okay, normal scenario. Let me show you one thing. Let me select top 15 records of this table. Then we'll see this got executed in less than like 1 second. Okay, so for you and for even me, this query is it cannot be an issue, because it is just executing within 1 second. Now what if this query is been hit a million times? Okay, so we'll come back to this scenario later. Let me show you one more thing. Before this, I just want to show you about something about execution plan, and also about DMVs. Okay, DMVs are dynamic management view, which are managed by a SQL server itself. Whenever the query hit, and it maintains some stats, and you must be aware of, like, there is an execution plan which is generated for the query. So all these things are available to you. You can look into them through this dynamic management view. So in this second method, we will be going into one level deeper. Now one more thing, when the query execution time is very less, you cannot catch it with this SP2, because this can only show the query which is executing for a long time. Because if it is getting served in less than 1 second, you will not be able to see that query within this with this method, because the time you see and next time you refresh, it must get over, like it must get completed. So SP2 will not help in this scenario. Now coming to this dynamic execution stats, this is done like views provided by SQL Server, which provide you the execution of other queries. Now let me show you one more thing, like select top 2 star from sales order detail. Okay, now if I execute this query and I go into this one and do it by order creation date descending, then I will find one query, one execution plan. Okay, now this is the plan handle. What I do is I just copy this plan. I have one more DM, that is execute query plan, and I pass this as an parameter to the function, and I execute it. I get the plan. If I open it, this is the plan for this select top 2 from sales order detail. Now if I close this and I execute this several number of times, okay, now if I go here and I check it again, it will not generate new execution plan. Instead, it has used the same execution plan, increase the execution count of that query, like we have executed it for 12 times, and total work time. Okay, now total work time is an addition to the previous work time. Like suppose a query got executed in 10 units of worker time. Now next time you will execute, it will increase the count to 2, and next time it take 18 worker time. No, then it will increase the 10 plus 18 makes 28. Now if the third time it got executed, the count will increase to the 3, and suppose it take 10 more, then it will add 10 to that 28 also, that it will make 38. So total worker time is increased again and again. If I execute it again and again, and if I just go again and execute this query and look into it, you will see the count is increasing continuously and worker time is also increasing. So worker time is kind of overall usage what that query has done, like used for in terms of worker time. Okay, now when this statement is it is not generating new execution plan, it is using the same and increasing the count and total working time. What if I change just a definition of my query? The query is same, I just entered one you can say break, like line break out there, and I execute this. Now if I go here, it will not increment that worker time. Instead, it will generate one more execution plan because definition of same query got changed. So for him, the previous running query and this query are totally different. These are not same. See, the definition of the query is same, but in actual, if you will go into the plan, if I go into the XML view, the definition of query is changed because there is a breakpoint. Does that make sense? Okay, now coming toward this one again, and if I undo it again and make it the original one and I execute it again few more times, and if I return back into this one, and I will see the last plan is again start getting incremented. Okay, means SQL Server keeps execution plan and maintains stats for same definition of a query. Now this scenario, this methods work very less when dynamic queries are coming into the play. Okay, suppose at runtime you are adding and removing the parameters, so at that moment there is some serious issue. There are few more methods in the next tutorial. I will covering those also, but when you are using SPs and queries which are fixed coming from the production, you can say software or something website like that, then for the same query, the same definition query, these query will get these stats will get increment instead of creation of new stats. Okay, now you see the execution of this query is increasing. If I undo it again and I execute this one and I execute this again, you will see there will be increase in the count of the query which we asked for. Okay, now if I increase it again, now this is the different definition of the query. Now if I check it again, the count of this execution plan is increasing. Now what if I enter one more enter to this one and I execute it again? Now if I go into the execution like check for this DMV, then there will be a new execution plan for the same query because the definition of query has changed. There are two line break instead. Okay, okay, I think I have just copied something different. Okay, forget it. Now I think I make my point clear. Like whenever you change the definition of the query, it will generate a new record into the DMV which we are using. So you can only fix those queries which are not changing the definition at runtime. Okay, most of the time this is a scenario like queries are not changing. There are very few queries which are in the project which are dynamic. Most of the projects use SP, so you can trace down which SP has been hit and all. So how this is how we will trace. Now coming toward this one. Okay, now as I told you, like this is the query like sys.dynamic. Basically these are the DMVs. Sys.dynamic execute query stats. Now if I execute this, I get the query stats. Now there are few things which I have to focus on. First of all, execution count. Second is total worker time. Okay, now as I told you, my query was simple. Select top 2 star from sales. Okay, let me change the database dot sales order. Now if I execute this, this is a simple query. Now here I will use this load generator. I will use this query and I will use like 200 concurrent connection. Like each thread will fire 200 concurrent user connection onto the server, and my still CPU usage is normal, and I start executing it. Now if I look into the server, CPU usage is going far above the normal scenario. Now see, this query was getting executed in few milliseconds, but still it is causing this CPU usage. So it is not always like big running queries can cause the issue. Okay, okay, sorry. Okay, that process got crashed. Okay, so that was the only point which I want to make. Okay, now coming toward the DMVs, how you will be able to check it. When we are talking about this DMV, I told you like we will be focusing on two things. What is the one is the execution count, and second is the worker time. Now if I just execute this same same view and order it by total worker time, I get few stats about like there is a query which got executed 18 times and having the maximum worker time. Now I can look for that query, like which query it is. If I go in here, I can just copy the plan here and execute it, and if I want to show, I can click and I can look, and this one was the union all query. Okay, now this one was a big query. It's execution time, like the total worker time was big, but its execution on the server is the execution count on the server is not so big. So the frequency of execution of this query is not so big, so this cannot be that much issue. Okay, could be the possible issue, but not be that much issue. Now here is one more problem, like there is a query which has been hit that much time and the total worker time is also big. So now I have to look for this query, like which is this query which is getting hit so much time. Now if I just go into the get for the query plan, query execution plan, and go into this one, and now this is select top 10 star from this. Basically I have executed this query before recording this lecture, like for around more than 600 iteration for 200 users, so it is a big count. So this is the query which is causing which got executed maximum hit. Now on the production server you can find with this way, like which query is getting maximum number of hit and in getting the total worker time increased, and also which are the longer running queries and what is the frequency of running those queries on the server. Now this is a query which got which took the maximum time, and the frequency of execution is only 1, so we must not be that could not be that much issue. Sometimes longer run queries are issue, like they can cause deadlock onto the servers and all. Now this is the same SQL Server query, I just must have changed some definition and I made it execute for a long time. So now this is how you can easily check like which process is causing maximum total runtime, or if you have one big running query which is causing issue, you can kill it through this few steps. Now the last one more thing I want to tell, DMVs are not only available for the queries. For procedure you can run this select dm execute procedure dot underscore stats. This will tell you the stored procedure which are using these, and the same are the parameters if I just want to order it by the worker time, and I can also go for that, and also I can go for the query execution plan through the same way which I used for the queries also. Now here you can see the execution count is this and total worker time. So this is how you can trace down both the issues. Now coming toward my few topics, like what we covered is, first of all, this tutorial will only help when you are confirmed like SQL Server is only the culprit. Now for the first method we will find the query which is causing which is issue with the traditional method, then we kill the process or taking any other necessary action required, because always killing is not option on the production environment. If it is a transaction, we cannot kill in between. Now coming to the method 2, that is going one level deeper, we use built-in dynamic management views. Those are sys.dm.execute which I showed you. These are the views which we are using. Now also we go for finding query which is having maximum total worker time or execution count. Then once we go to query, we can go for if they are select queries, we can, most of the time stress is caused on the server because of the select queries. Okay, because when the massive reporting queries are run on the server, they are most of the time they are found like it is found like they are the culprit, because when update and insert queries are running, they are supposed to do input output operation, but when it comes to the select query and they start doing input output operation on the disk, then they can cause severe problem if they are doing it on the big you can say on the big scale. Okay, now when we are having some of the select query, like we found the total execution count and the total worker time was big for a small query which response time is very less, then we have to go for like optimizing it. Like we can go for like creating new index if suggested or required, and by dropping index if required. Suppose there is an update query which is getting executed again and again, and there are 10 index which are getting updated whenever the update is done, because the column in the index are also getting updated through that update statement. Now when this situation comes, you must be using full cover indexes. it should not be updating all the indexes. Like there are 10 indexes when you update one column, so whenever you are updating this one column, it is causing update to those 10 indexes also. So 10 input output operation are extra, so you can go for full cover index in that case. And also you can drop those 9 indexes and keep one which is required, because sometimes I have seen like developer create index without knowing, basically they just know like index help in fast retrieval, but they don't know like they are also cause extra stress on the server. Also these are done by the developers. Here why the DBA comes into the play. Now also by creating the partition, if you have big table like the sales order we have table, we can create the partition according to the date and all, because we are not always pulling all the records. Suppose I most scenario I pull only the current or last 6 month record, so I should create 6 month partition. Okay, now coming to the changing the cardinality. When you are having a big joins query, you can change the joins and check whether the result is same, and you can change the cardinality according to that, so that SQL server can trim the result set which is retrieving from the server. Okay, now also by splitting long running update queries in the smaller units, like suppose I maintain 6 month partitions or 1 year partition and I am running the update query on the complete partition. Now partition is, suppose one partition having 39 billions or 29 billion or 100 billions of records, then it will take a lot of time, and during that time that partition will surely get logged. So what you can do is you can just split the partition, the update statement with 1000, 10,000 or lakh updates at a time, so that certain pages should get only blocked. Okay, so suppose I think I've covered, my tutorial will help you and how you can get like fix this issue. Now also if you want to contact me, my name is Yogesh Mehla and my website is textwire.in. My email ID is this one, yogesh.mehla@gmail. My phone number is this, my Skype ID is King Conference, and my Skype is this one, your Facebook is this one. So if you have any feedback, suggestion or any question, you can just directly contact me. And also the queries and this all stuff will be available on my website, on the YouTube. Whenever you are watching the video, in the description you will find the link. Thank you for watching the video. Keep learning. Enjoy.